Self-Realized Math and History, and we're going to be using the force. So, in this video, we're going to calculate how much force is being applied. And from Star Wars, they always say, may the force be with you. So we're going to be solving a story problem that is relative to calculating the force. It is Plankton is trying to steal the Krabby Patty formula on a Zamboni. The Zamboni will have to smash through the main doors to the Krusty Krab. If the Zamboni weighs 4,000 kilograms and is moving at 17 meters per second, how much force in kilograms is being applied to the doors upon impact?
Gotcha, Plankton!
On the contrary, it is I who has you.
The Clamboni!
Run, you fools! Run!
So we're going to try to understand how much force the Zamboni driven by Plankton is being applied on the Krusty Krab doors. To understand the force, there is a formula that we're going to be using. The formula is the amount of force being applied is equal to the mass of the object multiplied by the speed or the acceleration of the object. When you combine the two, you'll be able to create a force. But hang on, why do we have to use meters as in acceleration, and why do we have to use kilograms as the weight of the Zamboni or the mass of the Zamboni? So the question is, why do we use meters as a measurement for distance and kilograms for a measurement of mass? There is an actual reason why. So we're going to look at all the three letters and see why. We probably know what the letter F stands for, because that stands for the force. And that's what we're trying to look for to calculate. So this is basically what force is, right here. The letter M stands for the mass of the object. The mass of an object is actually misinterpreted in science classes, like physics, because if you say this golf ball weighs something, it does. And if you say if this golf ball has a mass, it does too. Those two definitions are different. The reason why is the mass is defined as how many particles are in that object. So the number of particles. So we're going to see, for example, how many particles are in this golf ball. The weight is a little bit different. The weight is actually going to be how much of Earth's gravity is being applied on the golf ball. So the weight is basically the Earth pulling the golf ball down to get its weight. Like, let's say you weigh 100 pounds on Earth. You would weigh different weights or different measures on different planets. Like, if I bring this golf ball to the moon, the weight will change. If I bring it to Jupiter, it will change. But if I bring the golf ball to both of those objects or planets, even though the golf ball will never change its mass because it's still made up of particles. So we're going to use kilograms for mass because the metric system clearly demonstrates how much an object has in particles, or how much particles are in that object. The imperial system, like pounds and ounces, is measured in weight. So we're going to use the mass for kilograms. To add on that, when you get the answer for force, you are not going to get kilograms as the answer right away. Because we said that we wanted to see how much force is being applied on the doors in kilograms. We're going to be getting a new measure unit called newtons. Newtons can easily be calculated and easily be transferred and converted to kilograms. But newtons is basically kilograms, but in a given motion. So the amount of newtons is going to be an object using force in motion. Because on Earth, we have 1 kilogram is going to be equal to 9.8 newtons. So, and if you put this golf ball to the top and make it fall, it's going to fall at 9.8 meters per second squared. If you drop this pen down from a top, it will fall 9.8 meters per second squared. So anything you throw off a cliff or throw off something, it will go at 9.8 meters per second squared. So with newtons, we're going to calculate how much force is being applied in motion.
This one's gonna be fun! We just whack each other with these giant ear cleaners till one of us falls off! On your mark, get set!
Sandy, are you sure we're supposed to be standing up here?
Go!
So anything that falls will always have a speed of this when you're falling to Earth. That is going to be relatable to the letter A in the formula, because the A is going to represent the speed of an object, or the acceleration. So, an object needs to move in order to smash through something. And acceleration is going to be very easy to understand, because for force to happen, you need to move. You need to charge up with energy to move around in order to have enough of that force to smash through the Krusty Krab doors. Here's an example. When you walk or when you run, you are moving. And when you are moving, you have energy. Like, I run cross country, and when I run, I have energy. But when I smash into a wall upon impact, that energy is going to try and make the person go forward. And there is force. So, it's technically
Nice throw!
So now we know why we use kilograms for the mass and why we use meters per second in for the acceleration. So now let's actually plug in the numbers into the formula and calculate the force. Okay, so we said earlier that the mass of the Zamboni is weighed in kilograms, and it weighs 4,000 kilograms. So we're going to put 4,000 into the formula. After that, we have to multiply that by the acceleration. The acceleration of the object, or the acceleration of the Zamboni, is 17 meters per second. So we're going to put that right here. We're going to put 17 meters per second squared. Now, when we multiply 17 and multiply 4,000 together, you'll need a calculator for this. You will get an answer of 68,000 newtons. The problem is, we don't want newtons. Newtons represents how much is being applied by motion. We want it measured in kilograms. How much the door is being applied with force in kilograms. So, we said earlier that 1 kilogram is going to be equal to 9.8 newtons, we have to divide 68,000 by 9.8 to get how much kilograms is being applied on the door. So 68,000 divided by 9.8, that is going to bring you 6,938.77 kilograms of force driven by plankton is being applied on the Krusty Krab door. And that is how much force is being applied. And let's see what happens to Plankton. Will he break through the doors, or will he stay stuck in the Krusty Krab and let Mr. Krabs take over the secret formula? Let's see.
It's working! I'm actually going to get a Krabby Patty! Come on, get out of the way! You're blocking the exit! No!
I'll take that. Brilliant idea to block the exit with your body, SpongeBob.
Thank you, Mr. Krabs.
You lose again, Plankton.
It looks like the Zamboni has broken down because it used too much force. And that concludes the video. I hope this video has helped you learn how to use the force in mathematics and physics. Thank you for watching Tao Ping and Liza Math Industry. Like and subscribe.